Okay, so we got a question right here. In practice, the resistance of LED does not stay constant. I mean, it is continuously being varied, right? The graph shows how current varies with potential difference PD from the LED for the LED. Okay, explain how the behavior of the LED shown in the graph will affect the time taken for the light intensity to decrease to zero. Okay, so we can see in the graph that the current is basically increasing, right? The current is increasing, the current is increasing, and the potential difference is also increasing. You can see from the graph, like when the potential difference is increasing, the current is also going up, the graph is going up, the line, the slope is basically going up, right? So we can say the resistance must decrease because due to the formula I is equals to V by R. Now we can see our potential difference is increasing, our current is increasing, so this must decrease, right? It's obvious. Okay, so now we have to now it asked us that explain how the behavior of the LED shown in the graph will affect the time taken for the light intensity to decrease to zero. Now we are in the discharging curve, right? The discharging part, right? So on the discharging part, our basically V decreases because you know the current the potential difference is being divided between the LED and the resistor, right? So we're gonna do the opposite of it. Now our current is decreasing, our V is also decreasing, now our resistance is increasing, you know, which means as because you know resistance means because the current will have difficult time passing through through wire, you know, because it will have you know high resistance, means it will basically, for example, this is my thing, right? This is my basically resistor, right? So the current will go zigzag 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 instead of going this straight line. Now it's not longer going in a straight line because this was only in this scenario. Now this one is in this scenario, right? Now this current is going like this like this like this because of the particles in it, because of the resistor. Okay, so this means our time constant will also increase, right? Because our resistor is increasing, right? So CR, you know, as we know the formula, so our resistor is increasing, so our time constant will also increase. You have to mention that. So it means the conclusion will be that it will take longer time to discharge. Let me write the sentence for you guys so you can get the idea. Okay, so I have written the sentence. So according to the graph, if the current and the V is increasing, the resistance is decreasing, right? But we are talking about the scenario when the capacitor is discharging. So basically our I and V are decreasing, which means our R increases, right? Resistance is increasing, our I is current, our V is potential difference, so our R is basically increasing, right? This means our time constant increases as per this statement, right? Okay, so it will take longer time to discharge. This will be our final answer.